In topic 3.1, the two learning targets are I can determine the domain and range of a relation, and I can determine whether a relation is a function. So let's start off with some vocabulary. Domain is just a fancy word for x's. They are the input of a relation. Now, a relation is just a set of ordered pairs, which we'll talk about in a little bit. The range, then, are the output. So we know that output is the x's, is the y's of a relation. So domain is the x, the range is the y. So I always like to put D for domain, R for y. So then it kind of spells doctor, or the abbreviation of doctor. So that's how I tell students to remember that the domain is the x and the range is the y. Now there's a few things that we're going to use to help us. The first thing is called a mapping diagram. Now, a mapping diagram is what we use to map the domain, which is our x, to its corresponding y. Or I'm going to put range, and then in parentheses I'll put y. Now there's another vocabulary word called set notation. And we use set notation when we are writing the domains and ranges separately. So we use this to write the domain and range separately. And we actually use the braces. They're like a fancier parenthesis. Please do not use parentheses because that stands for ordered pairs. So using these little squiggly braces. Now, if you're not good with writing the braces, that's okay. Just do your best to do like the squiggly. Now, mapping diagram and set notation have two rules to write. So when using the mapping diagram or set notation, you want to write the number smallest to biggest. And if the number repeats, write it once. Now, let's discuss real quick. So, domain, once again, is the input, or the x's. The range is the output, or the y's. Mapping diagram is what we use to map the domains to its corresponding range. Set notation is when we have to separately write them. So we usually write the domain and then the range separately using the braces. Now, when you write the mapping diagram or set notation, got to follow these two rules. You want to write the value smallest to biggest, and if the number repeats, you write it once. Now, I'm going to write a tree map to help you organize your thoughts a little bit. So, on the top of our tree map is a relation. Now, we hinted at what the relation was. It's a set of ordered pairs. Now, a relation can break off into two branches. So it can be not a function, which if something is not a function, that means a domain value maps to more than one y value. And then I'll call it a range, which is our y value. Now, it can be a function. A function is our other possibility. A function means every domain has only one range. So that means if I input 5, then no matter what, I'm going to output 7. Or if I input 5, no matter what, I'm going to output -8. It's unique. I guess I should say if x was -5, then it only goes to, let's say, 10. The x has one range, which we'll go into in a little bit. Now, a function can be 1 to 1, which if this happens, if no two domains map to the same range. So that means no range values are shared. And then for the function that's not 1 to 1, it's when two domains, 2 or more domains map to the same range. All right, so we're going to come back to this tree map to help us with our examples. Now, the first example is just recognizing domain and range. So when you recognize something, when you want to state something, that is when set notation is going to be used. So set notation is going to separate the domain, which I want you to write. I want you to write domain out, and I want you to write range out. I'm going to use the squiggly braces. Now the domain is our x's, and then the ranges are our y's. Now remember the two rules. If it repeats, write it once, and smallest to biggest. So none of my values repeat, and they're already in order, so I'm just going to classify them as 1, 2, 3, and 4, and 5. Now my range, on the other hand, is 11, 12, and 13. 13 happens 3 times, but I'm only going to write it once. Now you're going to do the same thing for try it, so if you want, you can pause it right now. Domain is going to be my y's. It's going to be my x's. Domain is for x, because that's my input. So I'm going to write them in order. Smallest to biggest, they're already there. And then my ranges are my y values. And it looks like those are already in order, and they don't repeat. Now for my b, my domain, once again, are my x's. So write them smallest to biggest. -3 is smaller. -1, 1, 3, and 4. And then my ranges, gotta be careful, they're not in order. So -2 is the smallest. I'm gonna kind of lightly cross it out so I don't forget about them. Then 1, then 2, 3, and then 6. So there you go. Now, for example 3, this is where we're going to use the tree map to really guide us for our answer. It says, is the relation a function? If so, is it one-to-one or not one-to-one? So notice up here, we talked about a mapping diagram. It's what we use to map the domain to its corresponding range. This is one of the most important things that we're going to use, and we need to follow this 2 rules. Write the value smallest to biggest, and if the value repeats, write it once. So this is what a mapping diagram looks like. It's kind of like 2 ovals. Domain goes first, then range. So our domain is our x values. So I'm going to highlight them in yellow, and I recommend that strategy. Smallest to biggest, so 1, and then 5, 7, and then 8. And then I have 2, 6, -1, and 0. So write that smallest to biggest. -1, 0, then 2, and then 6. Now this is where we map the domain to its corresponding range. So 1 is set with 2. So 1 is going to go to 2. 5 corresponds with 6. So 5 is going to go to 6. 7 goes with -1. And then 8 goes with 0. So, how to tell if it's a function or not? Let's do this. You always want to cover up the range to decide if it's a function or not. So I'm just going to cover up the range real quick. And look, 1 has only 1 arrow leaving it. 5 only has 1 arrow leaving it. 7 only has 1 arrow leaving it. 8 only has 1 arrow leaving it. So since there's only 1 arrow, this is a function. All right, so this is a function because every x has only one y value. Now notice it says, is it 1 to 1? So if you look, the domain of 1 has 2. The domain of 5 has 6. The domain of 7 has -1. Domain of 8 goes to 0. So this is classified as 1 to 1. Each domain has one range, and it's a different range. So they're not, there's no y value that's shared. So this is a 1 to 1. All right. So example B for this, it says, is this a relation of function? If so, is it 1 to 1 or not 1 to 1? So once again, and you can do this with a piece of paper. I have to scribble it out to show you. You want to look at the arrows only. Okay? So 1 has one arrow leaving it. 2 has one arrow leaving it. 3 has an arrow leaving it. 4 has an arrow leaving it. 5 has an arrow leaving it. So that means every domain only has one range. So this would be a function. Sorry, that should be y value. Now uncover the y, and now see how that this is not 1 to 1. It's not 1 to 1 because 1 and 2 share 17. 4 and 5 share 10. So this is not 1 to 1. Because the x of 1 and 2 share the y of 12, and the x of 4 and 5 share the y of 10. Now you want to be as specific as possible there. Talk about the x. The x is always going to come first. Talk about the y. Always going to come second. And be as specific as possible. Now, what I would like you to do is try it for number 3a and try it for number 3b. So you want to hit pause here. After you hit pause, let's confirm your answers. So you want to scribble out the y's, and then you want to look at the x's. -2 has one line, yay. 3, though, has 2 lines leaving it. 4 has 1. Since 3 has 2 lines leaving it, this would be considered not a function. Because the x of 3 has more than one y value. And you can be more specific here. you can say the x of 3 has 6 and 7. Or you can just write more than one y value. So why this is not a function, if you think about it, imagine you inputting 3 into an equation and you get 6, and your classmate puts 3 into the same equation, but they get 7. Both of you did it right, but you get 2 different answers. That can't happen. That's why it's not a function. So it's not a function because the x of 3 has more than one y value. Now, for part B, there's a couple ways that you can do it. You can look at all the x values. The x value has one y, this x value has one y, this one, and it goes on forever, right? Or something from middle school, the vertical line test, where you draw a vertical line, and if each vertical line touches your orange line once and only once, then it's a function. So B would be a function. Because every x value has only one y value. Now, if your graph was like a circle, let's say that this is, or an oval. Doing my best drawing an oval, guys. And you want to do the vertical line test. Notice my vertical line touches here and here. So since it touches more than once, this would not be a function. Because this x value has a y here and a y there. Because the x value has more than one y value. So vertical line test is super easy to do when you have a graph. But remember, it's a vertical line test. So you have to draw your vertical line straight up and down to see if it passes or not.